Hello everyone. In this video, we will be talking about how this NCP tool helps us in documentation of anthropometry data. This Google spreadsheet helps us in anthropometry data through this tab right here, highlighted in red. There are four major sections. Starting from the left, the documentation section. This is where the data entered in the second section, weight history section, are used to construct sentences for documentation. The second section is the weight history. This is where we will be typing in most of our data and the analysis would happen down here. And next is to our right, the reference. This is the reference used by Google Spreadsheet to evaluate a person's weight. And below it is the weight and height estimation tool, which can use a person's knee height, calf circumference, and other various measurements to calculate and estimate a person's height. Now, before we proceed to talk more about this tab, I must warn you that this tool is only meant to calculate and help in documentation of NCP. It cannot actually replace a living person for the critical thinking part of linking the different assessment categories together to help a patient. Now let's try this tool out. Again, this tool is linked with the CMHX, where the age of the person is used to determine if an adult standard should be used. Now the patient is 21 years old. If we key in today's date, let's suppose I'm in ward, I'm looking at this patient right now, and the patient self-reported his weight as 60 kilogram and 170 centimeter. His height will immediately be computed as 5.5 feet, BMI of 20.7, and according to CPG for Obesity 2004, he is at a normal BMI. I can choose to adjust his adjusted body weight, BMI, but it's not necessary in this case. So let's change the patient to a higher weight, putting him at obese class 1, and we want to reduce by 5 BMI, putting him at a 25 BMI. Now you see here the adjusted body weight will become computed as 72.3 kilogram. Ignore the ABW ADA 1996. It's supposed to use the formula by ADA 1996 to calculate the adjusted body weight, but the formula currently actually have a problem. Yes. So ignore that. Next is actually recording the history of this person's weight. Let's suppose this person was 120 kilogram in March of 2020. With the same height, he is at 41.5 BMI. If we see from here, obviously the person have lost weight from 120 to 90 kilogram. It is actually reflected here, difference with previous weight in terms of kilogram minus 30. Difference with previous weight in terms of percentage is minus 25%. What it means is today the patient is 90 kilogram, but since March this year, he have lost 25% of his body weight from 120 to 90 kilogram. Below here, there is also the lapse month and lapse week, and the average of weekly loss, bi-weekly loss, as well as monthly loss will be calculated according to the difference with previous weight. Again, we can add on more data, add on up to 5 data. 1st of January 2020, he was at 135. And last year, October, he was at 150. And again, last year March, let's say he is actually lower. He was at 120. Every single one of this data will have its BMI calculated and evaluated. Its adjusted body weight will only show if the patient actually, if you actually type in the adjusted BMI for the patient. And the difference with previous weight is also computed. 1st of March will be compared with 1st of January, 1st of January 2020 compared with 1st of October 2019. If we scroll down over here, you'll see a graph. This graph is used to plot and show us how the weight has been. So from the 1st of March 2019, starting from the earliest date, the patient gained from 120 kilogram rise to 150 at 1st of October, and then eventually drop in his weight until currently at 1st of October 2020. This is a trend line showing that there's a general downward trend of the patient's weight. Now if we scroll back up here, you see that there is one more section that we haven't tackled yet, which is this helper 1, 2, 3, 4 and this nature of report. This helper 1, 2, 3, 4 is actually meant for the spreadsheet only. It is meant to do some background work, so you don't actually have to type anything there, nor will it influence any decisions that you make. As for here, the nature of report, you can put in if the patient is actually self-reported, reported by, estimated, or weighed. Now, if we look at the dime here, on top, it says Anthro weight self-reported at 90 kilogram. This is actually according to this weight self-reported. If we can change it to weight estimated, again it will change weight estimated. And you can also put weight reported by mother. There seems to be a little bit of problem here, so we'll skip that. And the height centimeter can also change to height estimated, self-reported, etc. This part, nature of self-report, is actually for the weight history. So if the weight history is actually estimated, then you will see here weight HX EST. If we change it to self-reported, weight HX, self-reported 120 kilogram, and so on and so on. Weight pattern by default is decreasing. It will look at the trend line and calculate a value if it's negative or positive, and uses that value to decide if it's increasing or decreasing. This is not always applicable, especially when we have only a few readings, so you can come down here and choose to change it by yourself. Nature of weight loss, if there is weight loss, you can choose if it's intentional or unintentional. Let's put this patient as unintentional for now, and you'll see here in this NCP, this last row would say an intentional weight loss. It will also be reflected over here in a dime saying unintentional weight loss. Okay, that is for an adult case. But what if we encountered a pediatric case? So let's delete all of this data first. Make sure everything have a clean start. Let's go back to this and let's change this person to a 5 years old preschooler. Now when we come back to this anthropometry, you'll see that what used to be adult over here is now CDC, and everything that used to be highlighted in green is now highlighted in yellow, signifying that this spreadsheet, this tool, have registered this patient as a pediatric case, and by default evaluating his weight and height with CDC. You can also choose WHO for this patient by just pressing enter and choosing the WHO option. But please note that this would delete the formula that's inside this sheet, this cell, which means if this patient comes back to 21 years old, it wouldn't actually change back to adult. So let's undo. So if you ever did change it to WHO, note that the value inside of it you have to change it manually if your patient changes. So what I usually would do is just use one Google Sheet, one tool for one patient. Okay, now let's get back to this weight. Okay, you would see also that here would change to head circumference instead of ABW, BMI. Let's say his weight is actually reported to be 25 kilogram and his height is at 100 centimeter. And just on the third month, he was at 15 and 80 centimeter. Yes, so his age is at 5.0, 4.4, 60 months, 53 months, 25 BMI, 23.4 BMI. I included the month here because there are times when we would be dealing with infants where years are not relevant, are not suitable to represent the age of an infant. The height, according to CDC, 100 centimeter is at 3.2 percentile, and 80 centimeter is actually below at 0 percentile. The weight wise is at 98.1 if it's 25 kilogram, 13.8 if it's 15 kilogram. Let's try another weight, anything high, anything between 25 to 15. We should see a value between 98.1 to 13.8. With a height of 120. You must include the height. So the height is at 100 percentile and the weight would be at 91.6. If we further put it back, 18, the weight percentile will also change. Head circumference will only display their percentile if the standard that you are using have head circumference data in it. What I mean by that is for this Google spreadsheet, there is a built-in table and a formula that will calculate the percentile for us, but not all standards, not every CDC, WHO, Phantom, Preterm always have head circumference percentile and BMI percentile. If it doesn't have it, then nothing will be displayed. If it does have it, but the patient's age is already past what it can evaluate, then it won't display anything as well. But if it's built into this sheet, it can evaluate, then it will show. Okay, next is difference with previous weight. Again, it's calculated, and instead here we have daily weight gain status. Previously, if the patient is an adult, we have a lapse week. But if the patient is a pediatric, it will have daily weight gain status and daily height gain status. It will use the weight changes divided by day and then evaluate if the patient is actually within the recommended range for their age. And here you can also further tweak the data, and the weight trend is also displayed here as well. Next, if we come into this diagram, you see Anthro weight reported at 25 kg, more than 95th percentile. Instead of displaying 98.1 percentile, the Google spreadsheet would recognize, oh, this is actually above 95, so I will display more than 95 percentile. Height estimated at less than 5th percentile according to CDC 2 to 20 BMI, which is weight history self-reported, the overall weight change increasing in 0 weeks. Increasing in 0 weeks. Okay, so there are a few errors in the construction of sentences. When it comes to pediatric cases, you can see that there are also errors with the decimal places. We can edit this error later on. Later on, it is best for us to look at the diagram back again and then evaluate if we have to change any sentences to make it more make sense. But you'll see that if we ignore this decimal place, weight change per day in terms of kilogram is 0.04 kilogram. Daily weight gain is below normal because the normal range will be 5 to 8 gram per day. Okay, next is what if we encountered a pregnancy case? We can trigger this Google Sheet to start evaluating a patient's weight by pregnancy standards by coming to CMHX and choosing pregnancy here. Now when we come back to Anthro, you see that it is now written as pregnancy in this cell and colored pink. But one problem with there is a development that I haven't finished with this anthropometry tab, is that I haven't actually included the standards necessary for pregnancy. So that's one area of development. If any of you are interested, you can continue to add on to this sheet. But right now, this Google Sheet cannot actually do the pregnancy test. I cannot evaluate a pregnancy person's weight. Right, let's put the patients back to an adult case. And we'll talk about the weight and height estimation tool over here. And 135 with 170. Okay. You have to make sure that this is empty in order for the anthropometry to return it back to an adult. You see here, this is a weight and height estimation tool. Sometimes we don't get an accurate data like using the measurement of a stadiometer to find out the patient's height. We'll use knee height, calf circumference, MUAC, demispan, and arm span. The sex, you can change it over here. The age will be directly tied to the patient used in CMHX. Now let's say the patient knee height is 48 and his calf circumference is 25, MUAC 20, and demispan, let's give it 150. Arm span, giving it 150 divided by 2. Let's give it around 75. You see that whichever equation that uses any of the values here will compute when that value is available to them. It not only will compute height, but it will also compute the weight. And you see here also that there is a highlight of green, green, green. It will highlight the gender that you choose. If I change it to male, all of the M will be highlighted. You can then use the values that you find here after you filter through the criteria, choosing the best equation for any of them and move it over and input the data over here, making sure to put in that the patient's height or weight is actually estimated. So that's how you use this part of the cell. Next is original height, thigh circumference, mid-arm circumference, etc. The waist circumference and waist hip ratio, as well as this one from CPG for obesity, will compute the data according to what you input here as well as here. Let's say the patient's abdominal circumference is 90 and his hip circumference is 120. You see that the waist circumference of the person will be considered excessive by CPG for obesity 2004, but it's not considered excessive by WHO 2011. But if we put it at 120, you see that it will be then excessive. The ratio will be excessive as well. But a person will have to be built like a cylinder to take on that kind of value. Okay, so that is all for the anthropometry tab. Again, there are 4 major sections. Documentation section that uses data from WeightHX to construct sentences. WeightHX, where you key in your data and have the Google spreadsheet show you all the relevant analysis, relevant and available analysis, reference for your own references, as well as the Google Sheets and the weight and height estimation tool that you can use in the event that you can't get a person's height by stadiometer. There are a few flaws. For instance, this Google Sheet cannot construct sentence or evaluate a pregnancy case, and it only have limited data for the CDC, WHO, as well as Down syndrome and Fenton chart. I can only find out a specific range of age. I think it's until 5 years old for Down syndrome, and for Fenton it's only between 22nd week to 49, if I'm not mistaken. So it cannot actually evaluate past a certain age limit. And if there are any future research that find out more values, of course this Google spreadsheet is not going to have it, because you actually have to manually key into this Google spreadsheet. So it has a problem of not being able to evaluate a pregnancy case and limited data on the pediatric cases, and some issues with constructing sentences and decimal places, which can actually be resolved later on in the NCP tab. You can refer to the NCP documentation for further details. That's all for this anthropometry video. I hope you have found it helpful, and I'll see you in the next video.